창문 좀 열어줄래? 예. 소리 좀 되게. 안녕하세요. 다음 수업. 여기 다음. 치과 가려는 거. 치과요? 어제도 근데 이 폐진리가 있어가지고 임시로 조치라. 네, 빵하시. 아, 이번 뭐 하고 나서 스카이에서 데뷔 조회했고 정말 서울서 다른 거 답습했는데 째고 뭐 칼로 째고 이런 거 답습했는데 이는 진짜 형님 사랑니 없어? 나 있어. 있어요? 빼야 돼요. 내가 여기는 다 뺐는데 여기에 두개 땄어. 이거. 위에는 잘 달랐는데 내 아직 아래는 매국이 있는지. 아래는 매국 아니더라도 어렵다. 위에는 매국이더라도 쉽다. 맞아요. 저도 지금 여기 없고 하나 뺐고 하나는 아껴. 이상한 거? 근데 이걸 윈니는 쉽게 뺀다고 하더라고. 나름이 그냥 뽑듯이 뽑았는데 이거 반대쪽 뽑나 하니까 근데 내비 두죠? 그래서 야, 나도 그것도 하는데 양쪽 여기 위에 다 왼쪽은 쉽지 않았어. 이게 누워 있어가지고. 그래요? 쉽진 않았어. 아래는 얼마나 나 축구는 줄 알았는데. 이걸 잘게 쪼개서 이렇게 하는데 그것도 안 풀어가지고. 뽑아서 이렇게 보여줘서 뿌리를 조각하고. 근데 뿌리는 이제 그대로 약간 뿌리가 완전 내가 뺑뺑 꼬였더라고. 낙지처럼. 낙지빵처럼. 와, 이러니까 리스포기 골키퍼에게 지금. 당신. 슈퍼리. 커피? 그래? 지금 나도 진짜 지내 그러고. 모르겠네. 네, 안녕하세요.
Recording in progress.
오디오가 작동하는지 거기서 모니터링이 돼요? 두 개, 두 개 다 된다는 것도?
두 개가 나오는 거 모르겠는데 링크를 시켜서
싱크를 하면은 되는데 가끔 또 끊기더라고요, 저게. 그래서 모니터링을 할 수 있는 방법이 있습니다.
제가 중간에 밖에 나가서 따로 줌 들어가서
아니, 줌에서 되는 것보다도 이 두 개가,
개가 같이 되는
싱크가 되는. 줌은 뭐, 줌은 뭐, 줌은 하긴 해야겠네. 줌에서 하는 거는. When you use your notebook or yes. Okay, exactly. But you need to make the thing.
Okay.
And then when you have your lecture, you share on your screen at that time. Germany. Is it in Excel file also in 카카오? Is it 카카오에 내가 올렸던가? 네? 게시판에. There's a board. I don't know whether you're pressing. Back. We have a lecture today starting. We is sure. We have been impressed at this. But I could not finish up the second part of the maybe stuff there for what is the kind of high hope and stuff. And then second part of Listen. question? No, so, I will want to make a test. Trying to find out, but it may take time. Maybe we can use a couple to find out the answers. This one. After the blood check. Oh. appreciate it. And so participant who is planning the construction planner who make the ship should be involved in design. So there is a software called computer-aided process planning that is for machining process from the CAD system. And classification society has a regulation to check the safety. And owner is also important, but owner does not have such a skill, technology, so that they hire another person as a checker, surveyor. We call this is a representative. And model Beijing is a point tank where the minimized ship is tested to check basically the speed of the ship and also the engine size, cost analysis for the design, because we need to have a contract how much the ship should be contracted. $1 million or less than or higher than. We should have a contract. Equipment vendors as more equipment purchased from the market or by contract. So shipbuilder itself has a main body they make and then put most of the machineries and pipings coming, including also the block itself can be purchased from the outside, contracted. So that's why the outside people is more combat system for the Navy ship, important, right? Missile and radar. And acoustics also for the combat system. And this is what looks like a function here. The picture. Design tools, there is should be a previous designs so that there is a experience coming. Many ships already built inside the shipyard. The drawings and CAD system things. Operational experience also too. Nowadays more becoming important. So that comes from the sensor of the operating ships and their engines and other equipment. So it can be collected as a so you can use a sensor network or internet. And the ship geometry and we can make a model of them, so mesh models that perform analysis like CFD or 3D acoustic analysis, any others. So point tank now going into the digital world, not anymore physical.
Designing something like the hull of a ship can be an expensive process. So how do you rigorously test out a design before you even build it? A unique research program at the University of Iowa makes that possible, using sophisticated software, model ships, and an enormous indoor pool. Professor Fred Stern leads the University of Iowa's Ship Hydrodynamics program, the home of this high-tech facility.
These are called wave basins. You can see the wave makers at the far end here. They're plunger type. They go up and down. They generate either regular or irregular waves in the basin. The next part for us then is the carriage. This is a custom designed carriage. It follows the model. There's targets on the model that the cameras and the tracking system use. Ours is unique insofar as it's designed specifically to carry measurement systems to measure the local flows around the free-running models.
Believe it or not, this nearly $5 million facility was designed and built primarily for the purpose of validating or testing computer code. That code, CFD Ship Iowa, is a simulation software developed at the University of Iowa for the Office of Naval Research. In the past, Stern and his research team validated the code by running their models in a 300-foot-long towing tank. But as computer power grew and the code became able to do more advanced simulations, so it required a more sophisticated tool for validating.
Our codes developed very rapidly over the last really 5 to 10 years to the point that we were able to predict the exact trajectory of the model, including rudders and rotating propellers, and no longer restricted to captive simulations. Therefore, to validate it, we needed to see, well, how accurate would the trajectories be? By trajectories, I mean models, for example, you start out straight ahead, you give the rudder a 35-degree angle, and it's going to go in a circle. In fact, we can simulate things we can't measure. So you begin to see a major shift in the scientific method, where we went from Aristotle, okay, each of these steps are just little, steps along the way. We'll always need the smaller facilities.
Standard. So we should follow the owner's requirement. The main part of the requirement should be cargo capacity for a container ship, maybe TEU, 20,000 TEU or 21,000 or 15,000. Is inside the contract. The speed of the ship. Endurance means how long the ship can go without refueling. It is very important for electric car nowadays because of battery. For the ship, the fuel tank size should be designed according to the contract. If the ship is trying to move crude oil from South Korea from Saudi Arabia to South Korea, should be, the endurance. And also container ship, you should start from Japan, Korea, China, Singapore, and Saudi Arabia, and Europe. Norway, long distance. But that kind of ship, they may have a chance to fueling in the visiting port, depending on the ship. Sometimes they may fueling in the cheap place, like Saudi Arabia. They fill fuel tank and return back. No fueling in the Korea, return back to Saudi. So it's depending on your design. Rules of Classification Society, IMO, International Maritime Organization, and Health and Safety Commission, HSE, and government agencies. This is container ship of size. Basically, that there is a big ships. What is it? 12,000 TEU. Small ones, 3,000, 5,000. Looks like old Panamax. This is a new Panamax. So this one is, what is this? I don't know the number. And then the bay number, and also, what is it? This is not container ships. It is a Navy ship. Looks like a bulk carrier, passenger ship, container ship, and oil tank. So this kind of length. See the pictures. And this is a clean ballast tank or double hull. When there's a big oil spill in Alaska 40 years ago, they make motor regulations. Something like this is old type of single skin. Then we need to have a double skin here to protect oils are spilling out. In this way, there is a ballast tank around the cargo tank. In here, should be mineral. High, the heavy cargo, something like coal or ore, then you don't need to have a big space, volume, compared to the weight. But ship is governed by weight rather than sometimes in terms of volume. But heavy cargos need to be smaller volume, the heavy load or heavy weight. So that we have enough space for ballast. Also, there is another requirement coming from clean ballast tank is new trend that sometimes in old days, when crude oil cargo tanker, they full loading or at the Saudi Arabia, and no ballast, it is empty ballast tank, full cargo, and then come to the Korea, and they unload crude oil, empty the cargo tank, but the ship is whole empty, then you need to put some water inside the ballast tank to make some submergence for the systems. Function for the traveling. But in terms of Saudi Arabian Sea government, the Korean ship is coming, they dump out the ballast water to their port, near the port, to load crude oil. But they don't want to make such a dumping of water coming from South Korea, near South Korea, because of the small bacteria or something, maybe not good for their water. It depends on the situation, but then in general. That's why they make another regulation for making a clean ballast water tank. So somehow they should treat ballast water before principal continuous requirements, cargo, speed, and ship type. There are different ship types we'll see in the next slide. And proposal plans. What can be the engine? Diesel engine, gas turbine, nuclear steam turbine, or electric. This code though with combined diesel or gas. It is coming when the battleships, the Navy ships, because they want to make high speed in a short time. You will see in the race. And what can be the propeller? Sometimes they use a water jet. You see in the laser boat, small laser boat, there's a water jet coming. In the beach side, you may see the single person riding a water jet. But water jet boat. buoyancy of the vessel, how can they float? So this is a very traditional, based on displacement. Displacement is pushing down of water into the water, pushing down the displace the water. So they, in response, they give back to the buoyancy. And submarine too, and small water plane area also too, and on districts. Catamaran, they are all depending on buoyancy comes from districts. And also the other conventional small ships, also districts. So you take all these hydrostatics of districts. Archimedes theory, it can be applied. Then it comes with the dynamics of hydrodynamics of planar coils and surface steering, ski, water ski, water ski can be kind of this. So the big water ski attached to the ship, so that when the ship speed is low, they are submerged like an ordinary ship. The speed is going up, then we are trying to moving up. Okay. Similar to your ski, water ski. Have you tried water ski yourself? Nobody? Oh, yes. You know what's the meaning, right? You need a ski to take off. And then it comes to aerostatics of and not aerodynamic. So it is air cushion by pumping airs down. Concept design. Concept car, know about concept car. Hyundai Motors, they announce new fancy car. These are only concept car. They do not make them, produce mass production. They make only one car. But it's very fancy, and in the future car, same as a concept. At the starting of making concept, feasibility study, concept design, so you can do many other items like new ideas. And for envelope, the skin, outer skin, and internal subdivision, rooms, and bulkhead, ceilings, and floors, and dimensions, lengths, breadth, and breadth, and depth, and then coefficient, several coefficient, to see whether ship is full or high speed or slender, freeboard, deck house volume, and then old drawings, designs, existing drawings can be used as a starting point using software. So naval ship concept design process, feasibility, and then hull form, deck house configuration, decks and bulkhead, general arrangement, configuration, development, system design. System means machinery and also combat systems. And analysis for to get the performance, whether the design is good or not. Check. And design iteration, balance between weight and buoyancy, especially for, say, airplane, weight is very important. So similarly, the Navy ships has more importance on the weight. Or maybe can be expected air cushion vehicles, they may have a more critical control of weight rather than this kind of. You need only less significant weight control of the body. Also, stability, safety, strength, otherwise it collapse, and the internal volume for the cargo. For the, say, cruise ship, you need to have a good size of rooms, guest rooms, with a good views, outside views. So internal volume or area, you can say, energy balance between electrical power, steam, and compressed air, cooling, and then control. Archimedes, right? It's a small experiment that the tank is full of water, and there is a size, and if you pull you down, you say your weight is 55, and then if you are submerged, only remaining 5 kilogram means the displaced water should be 50, right? And then the remaining one, we can measure weight and displaced water the same. And ballast and buoyancy and displaced water VNC and rate is all same over. Probably for the chip is same, right? It is same. VNC is weight supported or force supported by the water to the ship should be the same as total weight of the displacement. More. Oh. It's running out. Yes, this is. More. The ship design.
아직도 19걷기 하는 어리석은 중생들아. 오늘부터 1일 1 딧을 피타거라.
학교에는 19걷기가 최고 아닌가요?
어리석구나.
Question? No. No. Please. Nice. 이거 맞는데? 안 봤어. 풀어. 그래서 내가 아까 안 나왔었을 때도 안 나왔어.
So I'm gonna explain the rule forms to you. So rule forms is like the base of how to build a ship. You start from it anyway. So as usual is the base. Talk about data. So we're gonna the general consideration, rule form definition, line of the team, the form of like. So first, when you build a ship, usually you don't build a ship for nothing. You have articles of it. So, and this purpose will change the shape of the ship because you don't have the same necessity for all kind of ship, you don't have the same cargo load, type of ships or passenger, and most importantly, you want to know how fast the ship will be because it's always about rolling at some point, so you need to be quick to deliver. 40 minutes, which is matter. And the ship's full form determines many of its main attributes. So the stability characteristics, the resistance, and the full power needed for a given speed. Seaworthiness, maneuverability, and road sparing capacity. So we build the hull according to all that, but it's also. So I wanted to talk about the boat speed, like actually does make kind of the same pattern on the water that ship or the waves in water are larger. There's where they have low speeds. So there's a link between the size of the wave, the length wave, and the speed of the wave. And so if your ship starts to go really fast, the wave will be bigger. And this is not a problem, but at some point, the wave with the length of the ship. And at this side, it's like the fastest the ship can go in displacement mode. So the teacher already talked about the displacement mode. So it's when you have the water in front, hitting the back to advance. And this is in a way, and it's what most of ship uses because it's more energy efficient. And also, and when you go faster than this wavelength, that is determined by the length of the boat, you will start to enter in the planning form. So, as I say, it's for like ski schematics and what is going on, the wind starts to go up and makes this kind of shape. But you need way more energy to go at this speed. So you don't want this the consideration like this. So usually the bigger the boat, the quicker more land, the faster the robots can go. So it's important to think about this. And so we have three big types of hull. Quite a lot with the displacement hull, which are the big ones, landing hulls, space hulls, things like this, and some that can use two types of. Also, not only the length notes is important for speed, and you have to get the drag the shape of the hull. So you have to work about it. Like I think most of you know that the spray is not the most efficient object to go faster into the water. Mostly streamlined body like planes or like that are way better. So you need to work also on the shape of your boat to make it go better into the water and to limit its drag. Yeah, an example. Also, do any of you have like why combo shapes are usually like square, like I actually didn't. I looked about it because I thought it might be interesting, and so I found it beautiful. Sorry.
Sound is not coming. Need to check. Unshare your screen first. Unshare. Okay. Unshare the red button, red button. Red button, right? And then share again. And checking the audio box. Share again. Share screen. Just screen.
Instead, deep keels are a very intuitive way of keeping a floating vessel stable. Essentially, you have a bulky buoyant part of the hull up near the surface, placing the centre of buoyancy relatively high up in the hull. The keel is much lower, filled with a really dense heavy material such as lead, iron, or, in the case of old ships, just rocks. The concentration of weight low down in the keel has the effect of moving the average position of all the weights in the vessel deep down into the hull. The force of buoyancy acts through a point higher up than the force of gravity, effectively creating a bit of a dangling effect, continuously acting to keep the vessel upright. As long as you keep the centre of gravity below the centre of buoyancy, it will be impossible to capsize the vessel. For now, we can just call this weight stability because the vessel's stability is provided by the weight located deep down in the keel. On something like a submarine, all of its stability is provided by weight stability because the position of the centre of gravity is the only thing you can control. Think about it. Once you're underwater, the centre of buoyancy is going to remain fixed no matter how you move, so the only way you can stay upright is to make sure that the centre of gravity stays down low, either through fixed weights in the keel or through variable weights in things like ballast tanks. It's a bit different on the surface, however, because the centre of buoyancy can move. As a vessel sits lower in the water, the wider parts of the hull become submerged, shifting the average position of buoyancy up a little bit. Assuming the position of the centre of gravity stays the same, the vessel will actually become more stable. The magnitude of the stability is provided by the separation between the position of the centre of gravity and the centre of buoyancy. A greater separation means there's a greater turning lever acting to right the vessel when it leans over. Conversely, a smaller separation means there's less righting force when it leans over. But the thing is, for a vessel to sit lower in the water, you need to add weight. On a cargo ship, the added weight will come from the cargo, which obviously needs to be placed somewhere. You can't put it all low down in the keel because there just isn't the space, so you end up placing it in the hold or even up on deck. As you add more weight around the hull, the centre of gravity of the ship as a whole will move towards the added weight. I'm sure you can already see the problem. The more weight you add up high, the higher the centre of gravity and the smaller the separation between the centre of buoyancy and the centre of gravity. The ship becomes less stable. This isn't such a problem if you only want to carry a small amount of cargo low down in the hold, but if you want to maximise cargo carrying capacity, you need a different solution, and for that, we can turn to some ancient craft for inspiration, the outrigger canoe. An outrigger canoe basically consists of a large hull which provides sufficient buoyancy for carrying lots of cargo, and an outrigger to make it stable. The centre of gravity of the composite unit is somewhere around here, and the centre of buoyancy is somewhere around here. Both are slightly off-centre from the main hull thanks to the presence of the outrigger, but notice how the centre of gravity is now above the centre of buoyancy. Now, when the outrigger canoe leans over, the righting force is no longer provided by the separation of forces alone, but instead by a movement of the centre of buoyancy, which in turn creates a separation of the forces. If you submerge the outrigger, the centre of buoyancy shifts out in that direction because that is the new average location of all the buoyancy. Apply to a modern ship? Well, it's all about the fact that the outrigger canoe doesn't rely on weight stability, but instead it relies on stability due to the form of the hull, so-called form stability. Form stability means you don't need to keep the centre of gravity down low, so you don't need to carry a massive weight in a deep keel, and you can load cargo higher up in the hull. Where weight stability relied on a high centre of buoyancy, form stability relies on a high metacentre, the point at which the force of buoyancy acts through the centre line. A wider hull will have a higher metacentre, because a small angle of heel will shift the centre of buoyancy further out. As long as you keep the centre of gravity below the metacentre, form stability ensures that your ship will remain upright. A wide, flat-bottomed hull gives you a good amount of form stability, with a wider hull being more stable than a narrower hull, and a shallower draft being more stable than a deep draft. Obviously, you
So depending what's the need of the ship, you need to be really careful not to make it like any ultimate great solution. Now, don't any of you might know the Tohoku ships, Japanese version. So someone wants to talk about it. You might know it better than I do. So the Tohoku ship was famous because they won a battle with way fewer ships the opposite side, so Japanese side.
The Royal Korean Navy during the Joseon dynasty at the beginning of the 15th century created the first sketches of what would later become one of the most powerful and deadly warships of the time, the Turtle Ship. The Turtle Ship, also known as Kabukson, was used from the beginning of the 15th century until the 19th century, being of great importance during the Japanese attempts of invasion of Korea at the end of the 16th century. Let's see now the 7 curiosities of this deadly weapon of war. Number 1. The Turtle Ship was the first battleship in the history of mankind. However, we must not ignore the existence of historians who do not agree that these ships had an iron roof, thus not being considered as 3. These ships played a decisive role in the Japanese attempts of invasion of Korea. Without this ship, the Japanese would have won probably. 3. Although it has a turtle shell design, the Turtle Ship has a dragon head in the prow. 4. The dragon head was not only decoration, it was also a weapon, and very interesting by the way. Toxic fumes. The ship had 12 cannons on each side. However, in the first years of the turtle ships, the cannons did not throw cannonballs, but arrows. These arrows were made of wood and iron typed, whose mission was to create large holes in the enemy ships. Furthermore, these arrows were thrown at 320 km. 6. On the upper deck, there were sharp iron spikes in order to avoid boarding. These spikes were incorporated because the Japanese Navy preferred boarding in naval battles, so the existence of these large spikes frustrated the Japanese tactics. 7. There are replicas of the turtle ship in South Korea.
So the Japanese, so we've seen the total ship, so it was mostly really large ship, really long, the protecting. Then we have the Japanese ship that were much longer, slender, more of a usual kind of ship. There are also different kind of tact methods. So the Korean ship were for cannon and Japanese one for rifle. So the range was different. So yes, we have like the first ship. It was wide and really short. So it also made them more stable, and the maneuverability was way better. And for the Japanese one, it was more travel and easy to control, more high speed. But the Korean one was very effective compared to the Japanese one. When we used to go about the other direction. On the other which wasn't possible. So also going with the speed, we also talk about speed efficiency for various problem variants. So usually you can see that for the boats it's way more efficient than rail alone. But it's still not enough, and not only about the environment, because when it was made, it was supposed to gain money. So usually, so less fuel was better to use less money for it. So there were ideas to create green ship concepts, like the NYK ship. Which was bigger in the thing, but that could use straw and wind power. So with the whole form, mostly you can try to be way more efficient on water and with the environment. And also, when you do a ship, unless it's like a fishing route, right? With other people, so you need to share your work and be able to share what you worked on. So you need to know mostly the important aspect of it. So we use a lot length of the road and array. So size the length of the ship, the water line length. So the length where there's water. So, and the length between perpendicular. So it's length between the stern repair line and the bow repair line. For the transverse or form characteristic, there's the breadth, wide, the width, measured at the middle of the ship, the depth, and there's design draft and sketching draft. So the design is at the start what you want and the scheduling will work on it. And the molded one is excluding the shell thickness with one. So the payload use all of the things you will put in the shape. Also for the midship section, so there's the camber is like the how but it's not always flat there, so it's raising the ship. And the tumble hole, it could be a flare when it's on the opposite direction. So it's the distance between the most larger point and the start of the deck. Then you have also every kind of frame, so small Mediterranean. Also the weight is really important because as we say, it changed what line the fluff. And so you need to be careful of what you're going to see the ship and to know at the start of your conception how much load you want to put on the ship. With the lightweight, the total of course steel weight and weight of so the weight, the carbon payload, consumables, TWT, from sets, and from the junior crew, and so the statement is also the front off. So it's the like when you deck, it's not the start of the hole. So usually it goes above the deck. So you have different types, the vertical one, types, in change also in which kind of sea you go traveling. So with bigger waves. And this is what this kind of explain how to draw the line of your hole, so to share the bottom of the hole and work on it. We can slide the lines of wood from the sides, the front part and the back part. This is on the plane frame. So you kind of want to have a full see the perspective. This is the result from every side, so from left, from side, front, the back of the shapes or wings.
Any question, Tar? Yes. You may share your slides.
Yes.
Normally, you may share the slide before the last step. Right, then we can go to the discussion. First. Second semester of master program. Is left. And this is my first discussion class. In the first level, I'm I do my best. But today is here, the sheet design procedure. I'm discussing the sheet design procedure and I'm explaining the space in the middle. Sometimes this is strange. Let's start with maybe and when you think of the condition for designing a ship, there are several factors, right? Among them, I thought the new important one is this question. Do you know this full work in SOLAS? Find out the terms, please. Safe build like this. That's right. And how about this plane? It's the same in the century. This and how about the plane? This industry is developed. The data factors are becoming crucially important.
I chose the topic related with SOLAS, not in the technical. So let's start. Uh, Firstly, I try to use power, but I had some time, so okay. So international relations for safety of markets is an important international activity concerning the safety of merchants. What is purpose of SOLAS? In registered by signatory states comply with minimum safety standards in construction and so on. Then, so, are there any provisions in SOLAS that will be revised? Show me the reasons. 참, 뭐, 해양특법 관련된 건데, 그런 것들이 지금 개정될 것 같은지, 개정이 안 될 것 같은지, 그에 대해서 좀 이야기를 해주시면 될 것 같습니다. The device called ship or truck is developed and changed in accordance with environmental regulation. This word. So, this solar. The rules. Right? No. Safety is also being revised to change people perception of accordance with marine stuff.
When I searched SOLAS Google, the last revision is 1974. 1974년. So I think there's no revision because it's already full revision for safety in motion. Yes. 네, 맞아요. probably there's no revision because of when we change class, we must be change this shift structure. It costs a lot of money or less capacity of loading. So many of ship or ship company don't want to buy that, but I such before there's no revision in SOLAS, but some change is happening IMO code, and there is some changes in when working on uploading and downloading, and there's some change when our sensors are coming or upgrade. So there's some changes or usually somewhere steps.
As technology develops, I think the ships are getting more automatized, so less crew members are going to be on board. So the reduction of the crew members on board would lead to revision of maybe escape routes, or there would be less needed lifeboats. So maybe we can use the space that was needed before to put the lifeboats and change it. I mean, those kind of device.
I see here something about 2012 May SOLAS amendments. I see one here to introduce a requirement for passenger ships for either onboard stability computers or shore-based support for the purpose of providing operational information to NASA for a safe return to port.
So okay. More hard. So how we can improve this cost.
So 15분까지. You may continue next time on Thursday. 네?
15분.
목요일날 계속 하자고. 연장전 하자. Sounds good. 벌써 Nice. So, see something. Right?
Yeah, that's what. Let's move the ship. Listen, oh my God. 중간에 그 수사고 발표하시기 전에 끝하고 녹화하려고. 전화기 안 들어가서 무슨 요새 녹화 중이신 거 하고 지금.
알잖아.
네.
오케이. 또 제가 있어.